Hello everybody, in this video we are going to talk about the greatest common factor and how to factor that out of any given polynomial. So in order for us to be able to do this, we need to talk a little bit about what a greatest common factor is and how we use it with polynomial expressions. So if you look at your screen, you're going to see that I have given you an explanation of how to do this with polynomials. We're actually going to be looking at two different things. We're going to be looking at the coefficients in the expression, and we're going to be looking to see if those coefficients all have the same exponent. So before we start, let's go ahead and remind ourselves what a coefficient is. So if you're looking at this polynomial expression, our coefficient is going to be the number that is attached to the letter, more specifically the number in the front that is attached to that variable. So if you look at this polynomial expression, 2 is a coefficient, negative 24 is a coefficient, and 6 is a coefficient. Okay, so the big numbers in the expression are our coefficients. So what we're going to do is we're going to look for a number that divides into all three. Now we need the biggest number that can divide into all three. So I'm looking for a number that will divide into 2, but will also divide into 24 and 6. Now the second part to finding the greatest common factor is that if they all have the same letter, or in this case the same variable, then we need to find the smallest exponent of the three. So if you're looking at the same polynomial expression, you're going to see that the 2 does have an x, the negative 24 does have an x, and so does the 6. So if all three of these numbers have the same variable, we're going to find the smallest exponent. So when we're factoring, we're trying to find something that they all have in common, so we can then break it down into a multiplication problem, into simpler expressions that when you multiply them would give you the answer. Now that doesn't make any sense right now because I'm saying it. You have to actually see it so it can click a little bit better. So let's see if we can find the greatest common factor for this polynomial. So notice that I've divided everything up because I want you to look at them separately and then bring it all together. So the first thing we're going to do is look at the 2, the 24, and the 6. Notice that all these numbers are actually even numbers, so we know that they are all divisible by 2. So 2 will divide into 2, 2 will divide into 24, and 2 will divide into 6. So our biggest coefficient divider is the number 2. Okay? And then since they all, so we determine that every single one of these coefficients has the same variable, they all have x. Now remember, this one's raised to the third power, this one's raised to the second, and even though this one has an x, if it doesn't have an exponent, just know it's an understood 1. So if I look at all my exponents, I know that this one is the smallest. So that means the variable with the smallest exponent would be x to the 1 power. Now remember, you can take that off or leave it on. It's understood either way. So we're going to take the biggest coefficient divider, we're going to take the variable with the smallest exponent, and this is our GCF. So we're going to say 2x to the 1 power. Now what we're going to do next is once you find your GCF, you have to figure out what will multiply by 2x to the 1 power to give you this as an answer. Now even though it sounds like that might be complicated, we're just going to divide and subtract. We're going to take these coefficients and divide it by 2. Then we're going to take these exponents and subtract it from 1. So we're doing two separate things. So let's do that. 2 divided by 2 is 1. This 3 minus 1 gives us x to the 2nd power. And then if we take the negative 24, divide it by 2, it gives me negative 12. 2 minus 1 gives us 1. And then right here, 6 divided by 2 gives us a positive 3. And if you do 1 minus 1, we get 0. So the 3 at the end has a no variable because it gives a 0 and we don't have to write down anything raised to the 0 power. Now here's the thing. We took this, found the GCF, and then we used the GCF to divide and subtract. So what's the ultimate here? Is we're trying to find something that will break down into simpler terms, but that if I multiply it back, it will give me the same thing. This lets us know that we did not actually change the problem, we just made it simpler. So what I'm going to do is I'm going to check my work using multiplication. So in a previous video, we talked about how we can use the distributive property to multiply. And we're multiplying the coefficients, but we're adding the exponents. So we know that 2 times 1 gives us 2. We know 1 and 2 give us x to the 3rd power. 2 times a negative 12 gives us a negative 24. 1 plus 1 gives us x squared. And if I do the last one, 2 times 3 does give me 6. And because this one has no x's and this one has 1, we just bring it down. Notice that I took this, broke it down into two factors that will multiply to give us that same polynomial, and then when I multiply it back, it gives me the same thing. So this lets me know that I factored this correctly, because we're not changing the problems, we're just breaking them down. We just are making them into simpler and smaller numbers. So I'm actually going to stop right here, just because I wanted to break down kind of what we're doing. But I'm going to go ahead and in the next video, we're going to do this. We're going to speed this up and we're going to do it a little bit faster. But I'm also going to show you how you can also use your calculator to find the greatest common factor by finding that big coefficient that divides into both of those numbers. So let's stop right here and I'll see you guys in the next video.